Okay, so hello everyone. Thank you for joining us today in this meetup, in this Madrid-GUG meetup. Today we have a very special guest, Cédric Champeau. I'm pretty sure that you all know him. He's working now at Gradle Inc., I think. And he wrote the static compiler, the Groovy static compiler. He knows a lot about Groovy, a lot about Gradle. Well, I will leave him to introduce herself, but first I'm going to introduce the group. We are the Madrid Groovy user group. You can see our webpage, our Twitter handle, and my own. I'm Ivan Lopez, I'm the organizer. So we have meetups pretty much every month. And now that we are online, it's easier to have meetups, and we try to get people from the community that it's complicated to have here in person in Madrid to do the talks. So if you go to our webpage, you will see like we have like 8 or 9 years of recording talks. Pretty much all of them are in Spanish, but the last 2 or 3 are now in English. So you can go there if you want to learn more about the group and about Groovy and about all the ecosystem. We have an open collective open for basically, we are a non-profit group. So basically we need money, just a few money for getting the, for the domain, for the meetup and things like that. So if you want to contribute to the group, this is our open collective. And we have a few sponsors. So Adaptavis now pays for our meetup account, and we are also using its Zoom account for doing this. B2Boost is one of our main sponsors in the Open Collective. They have offices here in Madrid and also in Brussels. They do a lot of things with Grails and Groovy. JetBrains, you all know JetBrains. We will raffle a few licenses or JetBrains products at the end. OCI used to sponsor us the drinks we have or we had after the talks. Now we don't have in-person meetups. So, and of course, grids that used to, or we used to have or use the screen capture to record the sessions. So we will have a raffle after the talk. So if you want to join or have the option to enter the raffle, we will raffle this time 2 JetBrains licenses, and we have also 5 tickets for Codemotion Madrid, which will be in a couple of weeks, I think. So if you want to enter the raffle, you can go to that QR code or that URL, bit.ly, Madrid-GUG raffle. I will leave this a few seconds in case you want to take a look. And after the talk, I will put this so anyone that wants to enter the raffle can join, and then we will do the raffle at the end. So that was all. Thank you very much for joining us today. And now I will leave Cédric to share his screen and start the talk. Thank you.
Okay, thank you, Ivan, and thanks for the invite. So now this is the technical part of this talk, how to share my screen.
There you go.
Can you see it?
Yeah, I think it's loading. It's black. Yeah, we can now.
Okay, cool. Well, it's blank here. Okay, now it is. Yeah, so thanks for the invite. Actually, it's my first talk since the beginning of the year, I think. So since the lockdown, I think it was back in March, I have done absolutely no talk whatsoever. So this is good to do from time to time, still exercise. So yeah, my name is Cédric Champeau. I'm working for Gradle. And thanks for joining today about this session. So I have a long history with Groovy, but let's just tell a bit more who I am. So I work for Gradle Inc. I started working, I think, 5 years ago at Gradle, and today I'm in the JVM team at Gradle. And by JVM, we really mean working on topics like making the Java ecosystem better, not working on the JVM itself. So I have worked on different topics at Gradle already, like dependency management, performance, and yeah, today my main focus is basically making everything in the Java ecosystem better. So yeah, just for the context, my story with Groovy started a long time ago. So I used to be just a regular user. I think I started before Groovy was even 1.0, so it's a long time ago. And I actually was a user in the context of DSLs with natural language processing. So I had written a DSL in Groovy to make it easier for linguists to write rules for an engine that was previously written with Perl, like many different software in the natural language processing. So I started as a user. I had some very specific needs, and basically I started submitting some patches. Then I became a committer in 2011. And yeah, I started contributing different features around the DSL, like sandboxing, and I basically fell in love with the compile time metaprogramming capabilities of Groovy. So I spent quite some time improving Groovy in that area with different AST transformations. And then I worked on the static compiler, and I was actually paid for that. So I eventually got paid by VMware back then, which was the company sponsoring Groovy back then, to write this static compiler. Also implemented features like traits. I don't know if many of you use that, but yeah, I worked on that, type taking extensions. And I think the last really big feature I contributed was this statically compiled template engine. So this markup template engine that I think nobody is using basically apart from me. Anyway, so yeah, story started a long time ago. That's actually when I met Ivan. And since then, I actually joined Gradle in yeah 2015, and I left the Groovy project in March in the past year. After some disagreement on the use of Kotlin in the Groovy build, actually. So it's a bit funny because this talk is actually about changing the Groovy build, and that's one of the reasons why I left the project. It was a bit complicated. I tend to say that I'm trying to use the right tool for the right job. So I'm using Groovy every day. I'm also using Kotlin every day. Of course, I write some Java code, and I think most of my code actually is Java code, Java 8 code, so not even Java 11. And yeah, so let's talk about the build. So I hope that many of you already know what Gradle is. In case it's not the case, well, there is a bit of context in the context of the Groove build itself. So Groovy is really an old project. If you consider that Java is 25 years old, actually Groovy is already 17 years old. So that's really an old project. And when it was created, basically there weren't many options in terms of build tools to build such a project. The only one which was kind of major was Apache Ant. So I know that we still have folks using Apache Ant to build projects nowadays, but I would say that most people are either using Maven or Gradle, at least in the Java ecosystem. So the Groovy build actually started with Ant, and some of the problems with Ant are that basically there's no guidance. Well, everybody was basically writing its own build. There wasn't any convention, whatever, etc., etc. And then Apache Maven came and went with this idea that, well, it's much easier to get into a project if all the projects follow basically the same layout. So if you find the sources in this directory, source main Java, if you find the test in source test Java, etc., etc. So the idea with Maven was really to have some conventions so that it's easier to get into a project. You always have the same tasks to call that are named exactly the same depending on the project, etc., etc. And there was an attempt to migrate the Groovy build to Maven, but because of the previous build and the project layout and how it was structured back then, it was actually quite complicated to migrate to Maven because the project, the Groovy project, didn't follow any of those conventions. So Maven was really like, if you have your sources somewhere else, you cannot really use it. So it was never finished and it was too complicated to do that. However, Gradle came, and Gradle is a build tool that was inspired by Maven in terms of conventions, but wanted to reuse some of the features that you could find in Ant. And actually, I'm not mentioning that in this slide, but there was a Groovy project called Gant, um, which is really G-A-N-T, so Groovy Ant. And this was basically only a DSL on top of Ant, a Groovy DSL on top of Ant. So it was possible to write an Ant build using purely Groovy code. But it didn't really define any of those conventions that we're talking about. And Gradle, in the other hand, came with this idea that builds should be easier to write, should follow some conventions, just like Maven, but should also allow some customizations. And Groovy was a perfect project for that because Groovy was using Ant before, and Maven was not flexible enough to build with Maven. So slowly, Gradle was introduced in the build, in the project, but as a parallel build. So we would still use Ant to do the releases, to actually test the project, etc., etc. But there was some kind of prototype of a Gradle build living in parallel. And this prototype actually lived up until the 1.0 release of Gradle, which was in 2012. And this is really where this build, this Gradle build, became the default. And actually, this is also, it also corresponds more or less to when I started really contributing to Groovy. So I worked both on features and for the Groovy language, and in parallel, I was also interested in working with the Gradle project. So I introduced some build in a, some build, and I really should say some build to the project. Like most of the errors that you're going to see today were written by me. And yeah, it's a bit my fault. So let's talk about the state of the Groovy build today. So if you check out Groovy today and that you check out the master branch, it's actually using what I rewrote a couple of weeks ago. So the master branch is using a new layout, a new Gradle build, etc., etc. And this is what we're going to discuss in this talk. If you check out the old branches like the Groovy 3 branch, Groovy 2, etc., etc., it's still using the old setup. So I'm going to use that to actually show you the differences in the build. So the state today was a bit of a sad state. Like it kind of used some modern features of Gradle, like the build cache, like to make it faster to build, reuse the outputs of different tasks from one branch to the other, etc. So it was possible to do that. but still the build was written by many different people around those 17 years. And it was still using in a lot of different projects, and especially in the core project, lots of conventions, if you want, which were inherited from the old builds like Ant and Maven. And it is kind of still the case today, but the situation is getting better. And I tend to think that it's better if you can actually slowly migrate from whatever pattern you used in the past. So say that you use Ant to build something and that you want to move to Gradle. It's actually a good idea to start with the capabilities of Gradle to actually model what you have today, like where are your sources, etc., and then slowly migrate to the default patterns and conventions. Some problems that we also had with the Groovy build is that it was really written with very early releases of Gradle. And as I mentioned, it was actually started when Gradle was not even 1.0. And sometimes when you read the build scripts, you find things like, this pattern actually has a much better solution today. We should actually change that and use the official support from Gradle. And nobody really did that. And sometimes you just read something like, I found some Jacoco code which was there, and it was saying, yeah, it's a workaround for that bug. And if you look at the bug, it was a bug from I don't know, 10 years ago. So is this bug still alive or not? Well, it turned out that it wasn't the case, but the build was still using those workarounds. So making some cleanup was something important in this process. I'm going to explain later what I mean by accidental dependencies. And the last really thing I want to mention about the state of the build on the Groovy 3 branch is that there is also a problem in terms of Gradle not providing enough guidance on what you should do. And sometimes you find patterns in the wild, like how do I share the version numbers in different subprojects? And there's no clear guidance on that. So, well, there used to be less guidance. So we spent the last couple of years dramatically improving the documentation around that. We're intensively developing new features to make it easier to declare all these. So even what I'm going to mention today, there are still things which are sometimes complicated to do and should not, and we are working on fixing that. So what I just want to say is that this is not always the build author's fault that something is not right in a Gradle build. Of course, this is not the only problem. There are very Groovy specific issues. Like Groovy is built with Gradle, and of course, Gradle uses Groovy also. So you have the Groovy DSL, which uses Groovy, and then we also have this Kotlin DSL that I mentioned. You can choose whatever. You can even mix Groovy scripts with Kotlin scripts. Just works. But it is a complicating factor because typically the way like the Groovy compile task is wired in a default Groovy project, if you as a user create a Groovy application, you just use Gradle and you configure almost nothing on the Groovy compile task because the compiler that you expect to get is the one that you're going to get from Maven Central. This is not the case in the Groovy build because what we do is that we're first starting to build what we call a bootstrap compiler, and then this compiler is going to be used to compile the Groovy sources of the Groovy project itself. So it makes the things a bit more complicated in the setup. And the last dimension that I need to mention is that Groovy actually comes with different flavors. So at least for Groovy 3, you have 3 different flavors. So what we call the classic one, which is if you just say nothing and that you just add a dependency in Groovy, this is the runtime that you would get. So it's a runtime that uses reflection, would generate some classes at runtime to make things faster, etc., etc. But a few years ago, for Groovy 2, we also introduced a different flavor, a different runtime, which is the invoke dynamic Groovy. And you can get this one if you use the -ind classifier on Maven dependencies. And this is actually a different runtime for runtime invocation of methods. And actually, right before Pivotal decided to stop sponsoring the project, stop sponsoring Groovy, there was a third flavor which was created that we call Druid, and this one is really for users of Android. And I'm not sure many people use that, but it's still alive. So yeah, this is basically all the different aspects that we have to take into account when we build Groovy. And there are some aspects which are much easier to deal with today with Gradle than it was, yeah, I don't know, 5 years ago. So why this talk and why it happened? Well, Apache Groovy 4 is coming, and you probably saw that if you follow the mailing lists of Groovy, there is actually an alpha of Groovy 4, and Groovy 4 is going to make some changes. So Groovy 4 is going to change the default GAF, so group artifact version coordinates of Groovy, and the old Codehouse Groovy, which was Codehouse was historically the original home for Groovy before Apache. So it was the Codehouse Foundation, and now it's the Apache Foundation. And so the coordinates, the GAF coordinates, are going to change from Codehouse to Apache. And I just mentioned this invoke dynamic flavor of Groovy. Actually, this is going to be the only available flavor, except for the Groovy one. So the old legacy runtime that I talked about is removed, and there's only going to be one flavor, this invoke dynamic version. And then at the same time, in a probably couple of months, something like that, Gradle 7 is coming. And one of the things that is going to happen in Gradle 7 is that we are removing things that we've deprecated for the whole 6.0 cycle. And one of those things is actually this old Maven plugin that was used to publish and is now replaced by what we call the Maven publish plugin. To me, it was an opportunity to actually leverage some of the features that we've been working on since a couple of years, and some features that were really released as part of Gradle 6 in terms of dependency management. So initially, when I started this idea of I want to work on the Groovy build, it was really just about let's just replace this Maven plugin with the Maven publish plugin. And then that's what I call the horror story started, because I realized that the build state was so terrible that I had to do something and make it really, really better. So yeah, I'm going to switch windows and show you what the old build looks like. So let me know if you cannot see my IDE. I hope you do see my IDE. Is it okay?
We can, yes.
Okay, cool. So I shared the right window. So well, this is a typical example of what you could find in the wild for old Gradle builds. So this is the main build.gradle file. So if we could take a quick look, you can see that you have a mix of this build script block, which is used to apply plugins and declare what the plugins are going to be on the class path. and it's using an old style, Maven-like coordinate style, and you have dependencies there, but we also use the plugins block. So you have a mix of the two, which is interesting. Then you have some configuration. You have the use of the x dot something, and I don't know if you're familiar with Gradle, but this is something that we don't encourage using anymore. And it's basically creating some dynamic objects that you can reference from other projects. So this one is just a closure, which is going to return all the projects which are not performance or binary compatibility. And good luck in understanding where this is used and why this is used. And well, just relying on the names of the project is not super nice. And then sometimes you have flags like, is this a release version? And this time this is not a closure. This is just something which is computed ad hoc. And then again, some plugin applications. So apply from, apply from, apply from. Oh no, this one is actually apply plugin. But okay, so sometimes you apply the plugin with the idea. Sometimes it's applied here, but it's not consistently applied. And well, okay, why do I also have an applied there? Oh, it's because it's an all project. Okay, so this root project is actually the thing that is going to configure the Groovy core project, which is the main library, but it's also configuring some sub-projects. Well, this is a pattern that we often find, but okay, let's say this is this pattern that everybody uses and it's fine. But now I can also see that I'm configuring this build here project directory, and you can see that I'm using target. Why is it so? Well, this is just the problem that the old build was using ant, and the default in ant was to use target as the directory name. So Groovy has been using Gradle for years, but we will still use target as the output directory for the different project. So it's just accidental configuration and accidental from the past. So it's used, so this all projects block is used to declare some repositories, and then we have some tasks being in line, or again, x.builddate, why it is not at the top level, I don't know. Again, some plugins, again, some task configuration, then task configuration, which is not actually on all projects, but only those ones. And well, this goes on and on and on and on. And in the end, you have like 500 lines of configuration code, call it whatever you want. This is absolutely not what we want to see in a Gradle build. A Gradle build should be really synthetic. It should be easy to read. It should be declarative, certainly not something like that. It's also using this pattern of apply from and then using a different build script to configure some aspects, which is interesting, but we are going to see how we can replace that with something even more interesting. Especially here, nothing tells you what this test is going to do. So what I discovered and rediscovered is also that sometimes you have this all project block, which is going to configure and apply some plugins. And sometimes it's doing some apply from, and this guy typically would also do an all project. So sometimes you have nested all projects. And this is just accidental because it's very hard to actually figure out what is going on. So I don't blame anybody except me. And yeah, this is basically history, how it is set up. But we can do much better. We can definitely do much better. This source set configuration is really something that is just specific to Groovy again. If you just follow the conventions and the usual Maven or Gradle conventions, you wouldn't need all these blocks. They are only there because the initial layout of the project was not using the conventions. So we had to say, well, the resources are going to be in source resources, not source resources main, whatever. So this is why it happens, basically, source. Okay, so I don't have to show you more than that, but basically this is what we want to avoid seeing from now on. And I hope that after this talk, oops, sorry, I didn't want to do that. After this talk, I just want to make sure that every of you have a better idea of what we want to see in a Gradle build. And this turns out to be a story that we started to promote. So internally, we have a project that we call the idiomatic Gradle project. And our goal is to promote what Gradle builds should look like now that we have all the tools that we wanted to have. And if something is missing and something is too hard to do, then we have to fix it and we have to make it easier for users. So this is not really a static thing. This is really dynamic. Like we try, we dog food what we have, and if something is too difficult or people just tell us, well, this is just not the thing I want to write, then we discuss and implement new features to make it easier. So what are our primary goals? First, clear guidance is super important. So people tend to say that with Gradle, there are many and different ways to do the same thing. I tend to say that this is not a problem in general. This is like any programming language, like you have so many ways to do a loop, but the guidance is important in this case because maybe this pattern is more interesting for this use case and this other pattern is more interesting for this other use case. And what is important is not that you have many ways of doing the same thing. It is what is the best solution to my problem. And the goal from that is to actually reduce the pain of maintaining this build. So if you have less to see and that you can basically refactor the build, it's just less maintenance burden. We also want to reduce the learning curve. So basically
It seems that we lost Cédric.
I'm back. Can you hear me?
Yeah, we can now.
I don't know. I was kicked out by Zoom. No idea why. Can you read that again?
It's loading. Yeah, we can see it now.
Anyone hear me?
Yep.
Yes? No?
Yes.
Okay, cool. Okay, let's move on. So yeah, reduce the learning curve, so make it easier to get into Gradle and understand its concepts. An important side effect is that we want to make the builds more performant. And in the end, all this is just about delivering better quality software. So if the build tool doesn't get into the way, you can actually increase the quality because you would get real meaningful feedback from tests typically. Ah. Um, so one of the key things to do is actually and to achieve is to have really declarative build scripts. And what we mean by that is that there shouldn't be any code really in these build scripts. So what you see in a build.gradle file, you should mostly have just some plugins being applied and then some configuration. And if you have to just take one key takeaway from this talk, this is really about the modeling stuff. What we really try hard to explain to people is that when you write a Java library, it is actually different from writing a Java application. And it is different from building a micronote application or a Groovy library or a Java, I don't know, Quarkus application, whatever. So all these different pieces, all these different software components have different work requirements, and all of them can be modeled in a way that it is easy to configure. So what other build tools like Maven offer is basically just a one-size-fits-all model. Like you have this POM file, and then you can declare all your dependencies, and that's it, right? This is really not what we want to do. We want to model the different things so that the consumers are aware of the producer, and we can do some optimizations, we can do some more linting, etc., etc. So let's just explore what it means for the Groovy build typically. I need to shut this phone off because I get all the notifications. So let's go in plane mode. Okay, sorry about that. So for the Groovy build, what it means is that within the Groovy build, we actually have different kind of modules. So we have those sub-projects, right? So one of them is just the Groovy core, and this one is, you could see it as the main project. This is the Groovy compiler plus runtime. Because the Groovy runtime is a bit special, it also provides the compiler as part of the runtime. So this is one module, and it's a bit special because this one is going to provide a compiler itself. And then you have Groovy modules like the JSON support, the date utils, those template engines I was talking about earlier. So those are different modules, and they are modeled differently than the core module. Then we have what I call some aggregating projects, like this Groovy all thing, which is not really Groovy all. We're going to talk about that. We have the BOM. So if you're not familiar with a BOM, basically a BOM is just a POM file without any artifact, just listing a bunch of dependencies, and you can see that as recommendations for versions that you should use. And then obviously we also have the distribution, like the thing that is going to generate the Groovy zip for the whole distribution, the SDK, etc., etc. And then we have a fourth category, which is basically all the rest, like utility projects, like the stress test, performance test. There's a binary compatibility project, which verifies if Groovy X is compatible with the previous release, etc. So these are internal projects not really meant to be published typically to an external repository. So just looking at this Groovy build, we actually identified that we have different kind of components. And what we're going to do is actually to model that. So if we take a look at what we have today after the refactor, this is what the Groovy date util project is going to look like. So this is the whole build script of this Groovy date util project. And what it does is just applying a single plugin, which is org Apache Groovy -library. And it just says, I am a Groovy library in this project. And then it declares its dependencies. And then we can see this configuration block, which is a Groovy library there. So because I apply this plugin, I actually enable this Groovy library extension, which allows me to configure things like this module descriptor. So if you're not familiar with that, Groovy has this concept of extension methods, extension classes, and basically takes a class as the first parameters of a method, and then allows you to enrich this method, this class with new methods. And for that, you need to declare what actually are going to be the extension classes. And yeah, this is how I do that now in this new build. Like I have this module descriptor block, which tells that. And if you compare that to what we had before, well, you could say this is almost the same number of lines of code, right? But there are some big differences, and I really want to insist on that. So first of all, if you just open this build file, you can see that it has no plugin applied. So it makes it super difficult to figure out what is actually going on. what is configuring this project? How can you find all the old projects block which are going to configure this? Or is it something else that is configuring that? Is it a plugin applied in the old project? Is it something in this test.gradle? You don't know. It's super hard to figure out, right? So with the plugins block that we introduced, actually it's super obvious what you have. You see, oh, it's a Groovy library, so I have this available. Okay. And then you can see this task, which is there. So this task module descriptor with a type. So it's super explicit what it's going to do. It's going to create a new task. Here is the name of this class. And then we can find again these extension classes. However, I had to create this task, right? I had to know what the task implementation name was, and every Gradle sub-project corresponding to a Groovy library was actually duplicating that. So duplicating this module descriptor and this compile java.depends on module descriptor. And guess what? The last line is actually an error. It's a mistake which was repeated in every build script. And it's super hard to figure out that actually this means nothing and this is not the right thing. It was just an accident, like people running Gradle test would make sure that by doing that, actually it's going to run compile Java. And because we run compile Java, this module descriptor is going to be executed and the extension is going to be visible magically at runtime. But the real dependency wasn't on compile Java, it was on something else. So yeah, this is really not something that we want to encourage. Instead, we want to say, hey, this is a Groovy library, and then if I change the implementation, how this module descriptor is going to be generated, if I want to use something else, I can just change the plugin and not have to go to all the different build scripts and update that. So it's just pure engineering like you would do for a regular project, but you do that cleanly in a Gradle build. Another example I wanted to show you is this utilities class, like this stress test. Now it has a different plugin like Groovy stress test, and then, well, actually, it has a different dependency set, and it's stress test implementation. And we still have this Sonar configuration because the Sonar plugin is actually doing what we said we shouldn't do, like blindly applying into all projects. Obviously, if I have something like this Groovy distribution project, this is not a Java library. I don't need a Groovy compile task or a Java compile task on something that is just going to produce a zip file, right? It doesn't have to compile anything. So it doesn't make sense to blindly apply plugins to all the different projects. You should really apply the plugins to the different kind of components that you have with diligence. So yeah, it's an explicit project. And then the last example I wanted to show is this bomb file project, which is what I call a Groovy platform. And there it's still a bit convoluted what you have to write, but it shows an interesting pattern. So if you remember what I showed you in this original Groovy build script, there was this block saying x.modules equal and then a closure, and it was filtering by project name. Actually, there are many different places in the old build where this filtering by name is done on different components. And guess what? It's super hard to figure out what is going on. So instead, what this project is actually doing is saying, yeah, I need to generate this platform thing. So I'm going to say, I have to depend on all the projects which belong to Groovy as a publication. And I can do that with these with plugin blocks. So instead of depending on the project name, I can just depend on the fact that the plugin is applied on my project. So to depend on all the Groovy libraries, I can just say with plugin org Apache Groovy dash library, etc., etc. So the aggregation aspect is something that is a bit complicated to do, even with Gradle today, that we want to tackle in the future. But still, now it means that whoever is going to add a new Groovy library project to the build won't have to touch this one. You won't have to search for all the different projects and say, okay, I forgot to add this one to this project name list in this obscure build file. This project won't change. It is just the fact of applying a plugin on the subproject that makes it automatically available to the bot. So we make some major changes in the build. The first one is that we get rid of this all projects block. Sometimes you don't have any other option, but for most cases, actually, it's much better to go from all projects to an explicit application of a convention plugin in every project. So what you've seen is that instead of using all projects, I was actually applying one plugin to every build script, which tells us what is this component type, what is this component. So is it a Groovy library, is it a Groovy platform, etc. The second thing that we're doing is that we are going to remove all those inline tasks. And if ever you need a task, custom implementation of a task, you should move that to what we call the build source directory. And I'm going to show you why in the following minutes. And then the last one is really changing from apply from, which basically takes whatever, to this plugins block. And it makes it much more convenient to reason about, because I can use also this with plugin block. So what does it mean? So the old build had this task, what its default Groovy method converter, basically. And again, you can see an explicit dependency in compile Java, which was also wrong, right? But forget about that. So this was an inline task in a build script. And what you can see is that because it is inline and doesn't even have a custom type, everything is done within the build script. So it means that the implementation of the task is within the build script. And the configuration of the task is also in the build script. So you mix the two aspects of the configuration and the execution phase within the build script, which is not what we want to do because we want to have declarative build scripts. So instead of doing that, what you do is that you convert that into a real task, so something that extends default task, and then we use all the goodness of the new Gradle APIs, like declaring what is the output directory, what is the input files, the class path, etc., etc. And it has a number of benefits, like I can make my task cacheable actually and make sure that it's going to not re-execute if I didn't change anything, or I can get that from the remote build cache, etc., etc. So I won't go into the details of what all those annotations mean, but the important thing is that as soon as you move the task from an inline script to build source and to a plugin, you get actually much more feedback from Gradle itself. And I found a number of errors actually in the build scripts of Groovy, sorry, just because of that, just by migrating from an inline task to a build source. Gradle was just telling me, hey, you put this annotation there, but it doesn't mean anything. It's not the right annotation. And you don't get this feedback if you do that within the build script. So at this stage, what you may wonder is, okay, so you showed me that all.gradle Apache library, Apache Groovy library plugin, and then this Groovy platform library, etc., etc. So do you have to publish plugins? I mean, it's super expensive to do so, and we have some good news, of course. So no, you don't have to. Everything can be in this build source directory. So if you're not familiar with this build source directory, this is basically a special kind of project that Gradle knows about, and which is about the build itself. And this is where you would put all the custom logic that you find in the build. Instead of having that in the build scripts themselves, you put that into this separate project. So you can have your custom tasks, you can have your custom models that I can also mention as extensions, and then you have all those different plugins there. And not so long ago, it was a bit of a pain to actually move from build scripts to build source, because as soon as you write a proper plugin, there is some ceremony that you have to write. Like you have to create a class which extends plugin. And then if you do so, well, actually you lose some of the DSL nifties that you have in the Groovy DSL or the Kotlin DSL. And well, we fixed that. And I'm going to show you what we call precompiled script plugins. And it's really super nice to migrate from the build script to the build source directory. So what it means is that we're going plugins all the way down. So something super important to say is that Gradle uses composition over inheritance. So if you're familiar with the Maven ecosystem, Maven is really about inheritance. You have this parent POM, and then everybody inherits from whatever is said is in this POM. So you cannot typically model this idea that you have this distribution project and this platform project and this whatever blah, because you automatically inherit from everything above, which we think is a bad model. Instead, we prefer this composition model. And it means that the different aspects of the project, like testing, like how do I write documentation, how do I compile, what are the customizations to the repositories, etc. Everything can be modeled as plugins. And then what is really nice is that some plugins can react to the presence of another module, another plugin. So when I was using this with plugin block, I'm actually saying if a project applies this plugin, then do this. So it removes a burden that was try to figure out if there's a task of this name. And if it is, I can assume that this comes from this plugin. Actually, you have a much better way to model that. You can just react to the presence of a plugin. So I mentioned this precompiled script plugin thing, and you can see that basically as lightweight plugins that you have within this build source directory. And most, if not all, of the custom build logic should move to those plugins. So either as a precompiled script plugin or as a proper plugin, it's up to you to decide what you want to do, depending on the implementation language that you want to use, depending on what kind of testing you want to do on the different projects of build source itself. But basically, all the logic should move there. And precompiled script plugins really make it easy to move from the build source, from the build script to the build source directory. So here is an example. So if I go to build source main Groovy, and then I have this file named all.apache.groovy-platform.gradle, this is a precompiled script plugin. And what it does is just applying this set of plugins. So what is a Groovy platform? This is something which applies the Java platform plugin, and then also applies my Groovy common plugin. I'm also saying that this is, well, the name is probably not quite right there. It's something that is going to be published to an external repository, so Maven repository. And then I also have this aspect of an aggregating project. So Groovy is something that aggregates different projects. And that's it, right? So this build script that I find in build source is a plugin by itself that I can apply by ID using old apache.gradle.groovy-platform, and that's it. This Groovy common plugin that I was mentioning does a bit more, and actually it's also applying plugins, but it's also doing some configuration which is specific to, well, it is not specific, it's actually something which is applied to all the Groovy projects in the build, but it's doing something specific only for the root project. And again, this is something very historical of the Gradle Groovy build. Well, I should say the Ant build, because in the past, Groovy was a single project. There was only one Groovy jar, right? And it had everything in it. So what you know as Groovy all today was actually everything into a single jar. So it was a single project, and it was the root project. And for Groovy 2, everything was split. So there was this Groovy core project, and then all these different modules, Groovy text, Groovy JSON, Groovy whatever, XML, and these were created as sub-projects in this architecture. One of the issues is that the Groovy core project actually remained at the root, and the root project is actually Groovy core itself. So ideally, in an ideal world, this Groovy project should be a sub-project itself, and you wouldn't have to do this special casing on the root project to create what I call the shared extension and versions. And you would only have the remainder here, which is basically setting the group that I'm going to use for publication and then getting the Groovy version. So configure all the different projects to use the same group and version. That's it. And then the Apache RAT is something really something specific to the Apache Software Foundation. This is just about checking licenses. So again, it's quite simple, right? I'm just composing things, like it's applying plugins and then adding some configuration on top of that. So it was actually creating a shared configuration extension, and this is what it looks like. I'm going to talk about this provider thing later, but basically this is just the configuration which should be available to all the different projects. So instead of using this x.block in the root project, I'm actually declaring an extension which is called shared configuration that I can use in all the different projects, and which is going to have some information like the Groovy version, the build date, some common configuration regarding the JavaC compiler, where I should set the installation directory when I'm going to do a Gradle install to get a local installations, etc., etc. So all this is actually applied and configured on the root, but it is available to all the different projects. So this is why I call that the shared configuration. And then depending on the type of project, I have different types of extension to configure in that project. So I mentioned this Groovy Dash library kind of project, so plugin. And when you apply this plugin, it's actually going to create a Groovy library extension where I can configure what is going to happen for a specific Groovy library. So I can tell, well, this should generate a Groovy for Android variant, or this should be included in the binary compatibility checks, or is this library actually included in Groovy all? Because this Groovy all project is actually not Groovy all at all. It's Groovy most common things that people use. So you have to say this project is going to be included in Groovy all, and this is where you would configure that. So this is just the extension class, and then within a project, this is what you get. You apply a plugin. This is a Java Groovy library, and then you configure it. When I call this method on the extension, so the class that you saw just in the previous slide, this optional module method call is going to say, basically, don't include that in Groovy all. This is just an optional module that shouldn't be brought if you just depend on Groovy all. And this is how it is done. So on the extension, I have this method, and it sets the internal state of this extension. So all the hard work of configuring is deferred from the build script to the extension. And the extension may create some tasks based on its internal state. That's basically the story, right? So what I'm explaining here is valid for Groovy, but it's obviously valid for any kind of project that you build. And I should mention that because I saw that recently, but the new Micronode plugin is exactly following this model. Like, it used to be a template that was generated with 100 lines of code that everybody had to copy and paste. But basically, what you should have is just a single line, like, I'm applying the Micronode library project plugin, sorry, and then you should have a Micronode block to configure everything, and that's it. Okay, so this is the most important things that I wanted to have in this talk. then we can talk about specific problems that you can find in any project using Gradle today. And those are problems of implementation, which are often problems to make things parallel, fast, etc. So problems of reliability, problems of performance, etc., etc. And one of them is reaching out to other projects directly. So we often see things like projects saying, my project depends on root project.task jar, whatever. So there are many different problems with that. But basically what you're doing when you're calling something like that, you are explicitly reaching out to another project state. And you have to know that this is totally unsafe in Gradle. There's no guarantee that it works. In practice, it works by accident. So it is fragile, it is unsafe, and we say that basically it breaks this notion of stronger encapsulation that you should have. Um, it was extremely difficult to get rid of that in the Groovy build. Really, really difficult because it was abusing that everywhere. So I'm just giving you a link here. So I'm going to paste the link to the slides later after this talk, but this is what you should do. If you do something like that, you should look at this documentation page, which explains what you should do instead of doing that. And you would get better parallelism, better performance, and safer, reproducible builds. So next thing I wanted to mention is this task configuration avoidance thing. And again, Groovy was created when this API didn't exist, so we cannot blame on the fact that it wasn't using this task of configuration avoidance. So before, you had this method called task.create, and you would give it a name, and then you would call a closure which would configure the task. And the problem with this method is that it is eager. It doesn't matter that the task is actually going to be called and participate in the task graph execution. It is always configured even if you don't need that. And it is a performance issue for larger projects. Like, you don't want to configure things that you are not going to be using. So instead of using that, you should actually call the task.register method, which basically takes the same arguments, but instead of calling this configuration block eagerly, it's going to configure that lazily. So only if the task is going to be called, this block, this configuration call, is going to be made. And there are many different methods. I only mentioned 3 of them there. So another one is this task.findByName, which is also eager. So as soon as you do that, it's actually returning a task instance, so something that is already configured. And instead, you probably want to use .named and then pass a closure, because again, this closure there to configure the task is only going to be executed if the task participates in the task graph. We also want to deprecate this all thing. So I don't know if you're familiar with this call, but if you do task.withType, it returns a collection of all the tasks of this type. And this is a live collection. So even if you add new tasks later of task foo, those are going to be configured with this all block. But if you call all, it's going to configure and create all those tasks there. So you shouldn't use that. You should use configure each instead. Just be aware of that. Interestingly, we have a problem with Groovy that we don't have with the Kotlin DSL. And this problem is that the Groovy DSL, it's actually quite nice to read, right? You have tasks and then you do test. But if you do that, you are actually creating this test task. Just by wanting to configure it internally, it's going to call this findByName. And this is not something that you want to do. So I had to change all the Groovy build to actually use things like task.named. And similarly, if you do task inline task creation like that, task my task, and then provide it with a name, it's going to call task.create and not that task.register. And the reason is just backwards compatibility. So you could definitely use the return type. So you could do a def foo equals test and this block. And if we change the way the Groovy DSL worked, basically we would break the contract of what is returned. So it just doesn't work. And when the Kotlin DSL was designed, actually this new API with register, named, etc., actually was already existing. So it was designed using this new API, not the old one. So be aware that if you do that in a build script in Gradle today, you are using the eager API. So I'm just mentioning that for completion, but it's actually quite easy to figure out that you are using that if you use build scans. So if you run the build with data scan, it's going to generate what we call build scan. You open a link and it's going to create a report and you can see what tasks are being eagerly created. So a good exercise just to run Gradle help, which should only generate the help task basically. And you see, oh, why has it configured the compile Java task? And then you can track down what plugin is actually doing that. So this API, so this lazy configuration API comes with this provider and property API that you saw when I used this extension. And it is super important to migrate to this new API too, because it solves a number of problems. One of the problems it solves, and it is a super difficult problem to solve, is it is this ordering issue. So you can get rid of almost all the ordering issues with this API. So all the after evaluate things that maybe you can find in the wild can be replaced with this provider API. So it is something that is designed to be lazy and functional. And I'm going to show you an example later. And the second advantage of this API is that it can carry some task information for some cases. So imagine that you have a task like that. So that just uses the output directory annotation to say, well, this is the output directory of my task. And you can see that it isn't using a file there. It is using this directory property thing. And because it is a strongly typed API, we can do smart things about that. And we can create it. I just won't explain what it does internally, but I can say the convention value for this guy is going to be a subdirectory of the build directory. So I'm going to create something within this builder directory. So if ever someone changes this builder, this task is going to be configured properly. In any case, whatever the order of the configuration is. And if you do like this, you can have some nice side effects. And I tend to say that if today in a build script you have to set an explicit depends on something, it is a cut smell. Depends on and an explicit depends on should almost never be required except for lifecycle tasks. So say that you want to run a task every time you run check. Well, yeah, in this case, you would have depends on to say, well, if you run that, you need to execute this one. But for wiring, you shouldn't need depends on, and you should depend on this API because it does that for you. So imagine that I have my task and that I register this task and I use this return type. And actually, when I call register, it's going to create a provider of task. So this is something that is eventually going to become a task, but it is just a provider of a task. What I can do is that my copy task can say, I actually copy things from this provider, and then because a task provider carries all the necessary information, when this is going to be called, I can actually track that. So if copy is called, this block is going to be configured. And because it's going to be configured, my task is going to be configured. And because we know that my task has a single output directory, we know that we can actually need, well, we need to execute my task before actually executing this one. So all the dependencies are implicit. and it helps in getting rid of these accidental dependencies that I'm talking about. Like, you just do depends on just because you figured out that if you run test, well, you should at least have something that is going to generate the module descriptor. But what task really needs that? Well, you should be super explicit. So this is a really, really nice way to get away with those problems. And to give you another example of what it means in terms of ordering, this is another example. Like I can create what we call a string property. So I just create a property of type string, and then I'm setting a convention value of hello on that. And then I use this functional type derivation, which just says map this property with this thing. So it actually is going to be the value of this hello provider. So it's going to be a string, and then I'm returning a different string. So the return type of this hello world is a provider of, well, JString in this case. So if I call this hello world.get the first time, I'm going to get hello world. But if later I'm going to change that and set hola, then when I call that later, it's actually going to be changed. So it means that this is really live and it knows about all the changes. So of course, in a real configuration, you wouldn't call this before doing that. You would do all the configuration phase, and then the actual get is going to be called by a task execution. So at task execution, all the configuration is done. So all the changes to the convention value have been made, and all the different tasks relying on this single property will get the same value, whatever order of execution they use. So yeah, we have around 15 minutes left. I'm talking a lot. Gradle has evolved. So there are some different patterns that were found specifically in this Groovy build that were much easier to do now. So one of them is this test fixtures thing. So what is a test fixture? It's basically an utility class that you need to have in tests and that you want to share for different projects. So in Groovy, typically there's a static Groovy, static type checking test case, and it has to be used by the Groovy core, but it also has to be used by Groovy JSON, whatever, because they also have statically typed test cases. And how do you share those test fixtures? Well, Groovy was doing that in a very interesting way. Actually, what it was doing is that you compile the main source test directory, and then all the projects which actually needed one of those test fixtures class added the test runtime class path of the main Groovy into their test compile class path, which is completely absurd, but it worked. You had way too many dependencies. You even had the tests of the root project into your own compile class path. Didn't make any sense, but it worked. Now we have a much better modeling of that. It's called the Java Test Fixture plugin. And basically what it does is that it creates a sub project, a new source set called test fixtures. And then within a project, you just say, my test implementation depend on the test fixtures of this project. So those are separate, and that's all you need to do. And then you don't reach out to the other project configuration, and you don't have different libraries that you shouldn't have in the compile class path. You don't meet the compile class path, etc., etc. So if you're not aware of this plugin, just use it. It's really nice, and it's not because it's called Java test fixtures that you cannot use it for Groovy. Also works for Groovy, so you can use source test fixtures Groovy and it works. The name is not well chosen as usual. Another things which have greatly improved in Gradle 6 is this notion of optional dependencies. So my mantra on that is that there are no optional dependencies, but only dependencies that you need when you use this particular feature. So Groovy has such examples, like you can use JPass, but you don't have to. You can use grapes or the @grab annotation, but you don't have to. However, if you use grapes, then you will need Ivy as a dependency. So all of these features of Groovy actually require a different set of dependencies. And in the Maven world that the Groovy build inherited from, the only way you can do that is by saying this dependency is optional. But it's not really optional. It's really something that you need if you're going to use a particular feature. So I changed the Groovy build to use the native support for Gradle, and in Gradle we'd call that feature variants. And again, I wrapped that into this Groovy library extension, and I'm just saying, yeah, please register this option feature grapes. And then in the build script, I can tell Gradle, well, for grapes implementation, you need Ivy. And actually, you don't need the transitive dependencies of Ivy, you just need the main Ivy library, and that's it. And for JPass, actually, well, you need this JPass dependency. What is going to happen is that when we're going to publish Gradle, well, all those dependencies are going to be published as optional dependencies in the POM file. But for Gradle, it becomes much more interesting. So this is just the kind of nightmare that the Groovy build had before. So we said that to publish that for Maven, you had to make them optional dependencies. So you had this PAM configure closure, which was itself calling a different closure, configuring something else. It was a bit crazy. And then when this PAM was configured, it was looking for an ext again, exting optional depths, and then trying to make them optional, etc., etc. That was a bit madness. All this is gone in the new build. It's just using the native system. So what it means is that the publishing status of the current build is much better, because what we get by applying this Maven publish plugin is that the optional dependency stuff is free. The customizations that we had in the POM files are actually done using a real API, so you don't have to do with POM file. This is all things which are supported, and it actually helps us for Groovy to publish all the different variants that we have. So again, let's take an example with this optional dependency stuff. So I mentioned that for Maven, in the POM file, they would be published as optional dependencies. But I also said that for Gradle, it would be more interesting. And why is it more interesting for Gradle? Because we're going to publish something called the Gradle module metadata. And this is an additional file alongside the POM file, which is a JSON file, which tells Gradle, actually, you have more than just those POM dependencies compile and runtime. You have different variants. And some of them are actually for JPass and for grapes. And if you want, as a consumer, to use Groovy and grapes, then you're going to say, I depend on Groovy with its optional feature, grapes. And then we will get this Ivy dependency for you. So you don't have to read the POM file and figure out in all the different optional dependencies which one is the right one to use to get this support. So you wouldn't get any class not found at runtime like most people get today, because they forgot to add this mysterious dependency on Ivy that they had to use if they actually used that specific feature. So I made some more changes to this publishing. So it's all standard APIs of Gradle. It's publishing Gradle module metadata, and it has a special publish task, which is interesting mostly for the Groovy maintainers, because what it's going to do is that it's going to create a staging repository in build/repo, where you get all the different modules which are going to be published, and it just lets you see what is going to be published on Maven Central or Bintro, whatever. So you can see all the different modules being published, all the POM files, all the jars, all the different signatures, checksums, etc. So very easy to figure out. Using this new format that we call Gradle module metadata, Gradle users also get more benefits from that. And I was mentioning that one of the aspects of the migration to the new build was to migrate from the Maven to the Maven published plugin. And what triggered that for me was this migration of this package, well, a group name for the GAF coordinates from org Apache, from org Codehouse Groovy to org Apache Groovy. Well, if you are a Gradle user and that you depend on Groovy 4, but let's say that transitively you also get Groovy 3, then Gradle would tell you, hey, you have a problem. You actually have two different versions of Groovy in the class path. You can't do that. You have to choose either use Groovy 3 or Groovy 4, but you cannot have the two. So Groovy 4 uses different coordinates, but the build tool is still going to be able to tell you that you have to choose between the two different variants, what we call the variants. And then, yeah, I was mentioning these opponent features. And last but not least, I mentioned this BOM. In Gradle, we call that a platform, but it has extra benefits compared to a POM file. And one of these benefits is that if you use a Gradle platform, you can get this version alignment for free. So what we call by that is that if you include transitively, you have Groovy, I don't know, 2.5.6, and then Groovy JSON 2.5.11. Well, because you have 11, actually it's going to align everything, all the different Groovy modules to 2.5.11. So this is what we call the version alignment. And this is just for free if you use a Gradle platform. Does it mean that it's all done for the Groovy build? No, it's not. And there are many, many different things that I'm not especially happy with. One of the things that would be interesting to do is using the new toolchains API that Gradle introduced in 6.7, which is out last week. So it basically lets you tell, well, this project actually needs JDK 15 to build and execute tests. And Gradle is going to download it for you if you don't have it locally, build everything, etc., etc. So you can do a lot of setup that was basically maintaining the different matrix of what you need. So I cannot use that in Groovy today just because this toolchain support is not ready for the Groovy compile task and Groovy doc, etc. yet, but it's going to be in 6.8. And the second aspect why I didn't do that, because I could have started to do that for the Java compile tasks, is that it also requires some changes in the build pipeline. So how Groovy is built, because you don't need to set up different pipelines in this case. You just need a single pipeline, and then Gradle would take care of executing everything using the right JDK. Yeah, that's all I had for this talk today. I just wanted to thank Paul King, because I think it's a 7-day effort full time just to migrate this build from the old state to the new state. Please take a look at the new state. I think it's interesting to figure out. You would see that the root project is not quite nice because of this mix. I mentioned that we cannot really move that to a sub project, or it would make the backporting the fixes from the different branches harder because they wouldn't live in the same source directories. So the root project is a bit special, but all the different sub projects are much nicer to use now. And yeah, 7-day effort. I introduced many build errors and regressions during that process. Hopefully now it's much more maintainable. So yeah, thanks for listening. And I guess I have a few minutes for questions if I didn't kill everybody.
Thank you very much. There are a lot of interesting questions here. We have one from Martin Erdmann. What are you using the statically compiled templates for? Because you mentioned at the very beginning that probably you only use that.
I use that to generate, to me, I typically had some test reports or reports, HTML reports that I want to generate, and I was using this template to generate that. So it was HTML generation. So it's a really markup, but instead of having to figure out if something is in the binding, the compiler would tell me, and the performance of the generation of the template is just excellent because it's all statically compiled.
Yeah, another one when we are talking about the Groovy build, kind of using the same template structure that Ant, Martin asked, isn't the fact that you can reconfigure conventions to match projects structure being sold as a strength of Gradle?
Yeah, so that's what I say basically. So one of the strengths of Gradle is that you can define your own conventions. But what we saw in practice is that people are doing that within the build scripts. And because you do that within the build scripts, it actually makes them look complicated when they are not really, because these conventions should be defined in the plugin, and then the build script should just apply the plugin which defines the convention. And in the end, if you move from custom conventions to the ad hoc convention that everybody uses, you can do that gradually. So we recommend to move from custom conventions to the ad hoc of the market.
Yeah, the next one from Vladimir Sitnikov is related to that. He was asking that when you moving from Ant to Gradle, for example, maintainers often require that it is Gradle that needs to be configured rather than moving files to accommodate the new
Yep.
build tool, right?
Yep.
So yeah, what's your thought, Matt? You already answered that.
That's exactly the case, and migrating from Ant is actually quite easy from Gradle because we have this Ant builder that you can use in a task. So you can call Ant task directly from Gradle, and actually the Groovy is still using that at least for a couple of use cases. So that's what I'm saying, that migration is not finished yet. So typically we use a jar task, which is probably something we could replace with a shadow plugin or maybe with something bundled in Gradle in the future.
Another one from Martin. What should you use instead of using all projects and so curly braces and subprojects block? I use them a lot because that's what I learned from Jeb's build, which is probably a need for an update now.
Yeah. So what I said is that instead of having all projects apply something, you can have a convention plugin which define what is the kind of project that you're using, and then each build is going to apply this plugin. So obviously it doesn't work in all cases, but there's a big advantage in that because it makes it super explicit what this kind of project is. Um, just mentioning that for some aspects like declaring repositories that you're going to use, almost everybody uses all projects block, right? Like all projects, and then within you have these repositories. And this is exactly what I'm mentioning when I say that the idiomatic Gradle project is about fixing that. So in Gradle 6.8, you will actually be able to define the repositories for the whole build within the settings instead of using the all projects block. So you can make sure that every project uses the same repositories everywhere.
That's cool. Another one from Ihor. If I have a project with 300 plus modules, what would be an alternative to subprojects all projects?
Well, my answer is not different from the previous one. I think you should still model what each project is, and I would even say that it's even more important if you have a lot of different modules, because the more sub-projects you have, the more likely it is that you have some slight differences between the different projects, and they are not actually the same kind of components. So it's super important to make a difference between those different kind of components. Like for Gradle, typically we have some core modules, and then we have plugins, and you don't configure the plugin like you configure the core project. A plugin needs to come with a different plugin descriptor with services, etc. So all these need to be configured. And if you use the all projects block, then you're blindly applying the same plugins to every project, which is not something that you want.
Mhm. Another one from Vladimir. What do you think of a convention like add Kotlin plugin if source main Kotlin is present? That is one of the reasons to use all subprojects, and then if source main Java exists, apply Java, etc.
Yeah, so we have ideas around that. So it's the next level of conventions. Like instead of saying apply this plugin and then basically it configures this way, you could rely on the fact that there is some specific layout and then discover. There are pros and cons on both approaches. The pros of this automatic applying is that it's easy. The cons is that well, it takes more time at configuration time because you have to scan the directories, etc., to figure out. And for larger project, it actually matters.
Another one, what is the recommendation to use extension values? Does that mean after evaluate should be used to analyze the values in extensions and configure tasks?
So in most cases, you shouldn't have to use after evaluate anymore. There are still some cases and valid cases for that. In most situations, this is because you have to bridge between tasks or extensions which use the provider API and tasks which do not, which is also the case in Gradle itself. So we have some plugins which still use the old APIs for backwards compatibility, etc. So sometimes because you have that, you have no other option than using after evaluate. But in general, I would just recommend to create extensions, providers on both the tasks and extension, and you just use that.
Okay. Is Java toolchain API available for Java exec tasks?
Yes. Yeah, so toolchains is really cool stuff, really super nice. So you would say in the main build script, you just say, I'm going to use Java 15, and by default, what it's going to do is just configure all the compile tasks, Java compile tasks, all the test tasks, and if you have a main, so Java exec task, it's also going to use that. So for all Java, pure Java, it's already working perfectly. And what it lets you do is that it doesn't matter what version of Gradle of JDK you use to run Gradle itself, because the build says I need 15. So it's going to, you can run Gradle with 11, and then the build is going to make sure that the JDK that is used to compile and execute is 15. So yeah, you can do that.
And I think this is the last one from Jorge Aguilera. Do you know how much time the build time of Groovy 4 was before your change and now that your changes and your refactor is merged?
I don't remember exactly, but what I can tell is that I had already made some changes in the past to make the build cacheable, but there were some quirks because of all those implicit inputs and plugins actually hooking into the configuration of this specific task and things like that. So it's actually still quite fast now. Like you can build, test everything, publish in under 10 minutes. Uh, yeah, and probably even faster. So
Wow,
yeah.
that's good. Yeah, so I think that's pretty much all. So thank you again very much, Cédric, for talking in our user group here. This talk has been amazing. We need to take a look at the slides and at the video because
Yes.
you shared a lot of things, and now
Yeah,
all
yeah,
of
yeah.
us we need to take a look at our build scripts and fix everything.
So I'm going to share the slides on Twitter right after this talk. So I'm just going to the first page. If you don't follow me, you can follow me at this. And then, well, yeah, in the next minutes, probably it's going to be shared.
Yeah, don't worry. So yeah, I think that was all. So now we are going to stop the recording and we will do the raffle. So thank you all for joining us, and we will see you in the next meetup. Thank you.